Hello, everyone. Good morning, good afternoon, wherever you are in the world. Thank you for joining us. This will be the first of the series of webinars from Sencore. It is, the leaves are changing. We've got the cooler evenings and, well, it's webinar season. And so we're ready to get it kicked off. Here we're going to talk about BISS CA, the new scrambling and security protocol for both satellite and IP contribution and primary distribution links. So we want to talk about that technology a little bit, give everybody a better understanding of, kind of the changes. BISS has been around for quite a while, but what changes have been introduced over the last year or two and kind of what's happening in the market right now as we speak around this technology. So I just want to give everybody a good explanation, good understanding of not only the technology, but also how Sencore has been able to help our customers take advantage of this new protocol. Before we get into that, I did want to highlight our fall virtual events. So obviously today, you all are attending the BISS CA technology overview with myself, Aaron Doughten. Tomorrow at 10:30 a.m. Central, Jason Dabbert will be talking about internet delivery protocols. And then on October 8th, Seth Vermolm will be talking about ATSC 3.0 and some of the activity that Sencore's been really heavily involved with, especially over the last, well, I would say pretty much this year as we've introduced some new products, got really kind of much more intimately familiar with the technology and stuff like that. Seth will kind of shine some light, maybe demystify the ATSC 3.0 workflows and some of our products and stuff like that. So be looking forward to those over the next couple days. Just want to do an introduction of myself. I'm Aaron Doughten, your presenter today, product manager here at Sencore. We also have Seth Vermolm and Jason Dabbert, who are both panelists here with me. They're going to be kind of managing the Q&A function. So as we go, please put your questions into the Q&A function. And as we get kind of to section breaks and stuff like that, what we'll do is go through and answer as many questions as possible. And these guys will kind of help me organize and sift through those things so we can get as many of your questions addressed as possible. And our email addresses are up there as well. So if you have, questions after the fact or want to get in contact with us, I don't know, if you have a more in-depth conversation you want to have or some ideas and things like that, feel free to shoot us an email and let us know your thoughts. It's just a quick agenda. We're going to give just a short history of BISS. So this will be not only BISS1, but also BISS2, which I feel like has already kind of faded away. But we'll talk about kind of the improvements to the BISS protocol that was made. And then, of course, dive into really kind of the meat of the presentation and talk about BISS CA protocol, the different workflows, what are the advantages to our customers, and kind of what kind of power does that give everyone by adopting BISS CA. And then we'll start talking about BISS CA with Sencore and how we've integrated it into our products and how we can kind of build a solution around this particular protocol. Whether you have existing, MRD receiver decoder from Sencore type infrastructure, we can help with that in addition to new products and new platforms that we've introduced as well. So we'll be sure to highlight that. And like I said, we will address questions from the Q&A as we go. So we'll kick it off with a short history of BISS. So BISS has been around for quite a while. Stands for Basic Interoperable Scrambling System, introduced in 2002. Primary application was securing satellite links. Back in 2002, that was the way of moving things around the world. And of course, as you broadcast high dollar content over satellite links, you need to be able to secure it. And so just the basic BISS1 protocol was I guess, come up with by the EBU and a group of broadcast hardware vendors. It was a combination of DVB-CI scrambling algorithm, which is a scrambling algorithm that's been around for quite a while. But one thing to highlight, this particular scrambling algorithm was optimized for hardware and bad for software. So that might have been a good thing way back in the day. I say back in the day, 2002. But back in the day when, all of pretty much every broadcast workflow went through a series of chain of hardware equipment and really nothing to do with software at all. So having it optimized for hardware and being bad for a software application actually made a lot of sense with the protocol. And then of course we had DES encryption standard, which by today's standards is a pretty low level encryption standard, pretty easy to crack, even with just the basic, basic computer software, hacking tools and all that great stuff. I think they can be cracked quite quickly. And of course, that's the whole point of BISS and encrypting your satellite links and your content is you don't want people to just randomly downlink your satellite signal or intercept your IP protocol or your IP signals over the internet and just being able to watch that content, to record it and rebroadcast it on YouTube or a Slingbox or something like that. That's exactly what you don't want to happen. You need to be able to secure that high dollar content and make sure that, as a content provider, you're able to monetize that content and people aren't able to just steal it. So of course, encryption is key in that case. So just kind of stepping through the basic BISS1, Mode 1, to really break it down from a super, super high level, this is essentially just a password. You're literally just entering in a session word at your encoder, your multiplexer, your modulator, doing the key exchange out of band. And by out of band, that's a really fancy way of saying, call the guy up and literally give him your session word or your password, or send them an email, and then copy paste that into your receiver decoders. And then you have a secure link is kind of how that works. So it's pretty basic. It's a symmetric cipher on both sides. So there's the same password essentially, or session word on both the transmitting side and the receiving side. And of course, intercepting those emails or overhearing a phone conversation wouldn't be difficult necessarily. So of course, kind of at risk of just getting those keys intercepted or cracked on the other side if you can receive those signals on the other side as well. So Mode E introduces just a little bit, I guess, another layer on top of the session word, and actually encrypts the session word to what's called an encrypted session word. So we mix that identifier, that ID, with our session word in order to make our encrypted session word. The ID is embedded actually in the receiver decoders, usually from either the providers or actually at kind of the head ends and stuff like that. These keys are injected by someone and password protected on the IRDs themselves, so that they can't be extracted out of the receivers. And then the keys are again exchanged out of band, and then the ID is mixed with the session word in order to decrypt not only the session word but the full stream. I put this one in here as kind of a joke slide because a lot of people go like, well, do you support Mode 0? This confused us in the really early days of Sencore and implementing BISS, which is kind of a funny story. But, of course, being in an encryption standard or a security standard, it's written to be almost purposefully confusing or misleading just to enhance the security side of it. And we struggled to figure out, well, what is Mode 0? Well, Mode 0 means it's disabled. There is no security, there's nothing. So if you support Mode 0, that means you just don't support security at all. So really the only thing you really need to worry about is Mode 1 and Mode E with these particular algorithms and security standards. So if we have any questions, I didn't see anything. Okay, so we're good to go. So we'll keep moving on. We'll talk about BISS2. So this was an evolutionary step in the entire BISS protocol, introduced back in 2018. Really, the workflows in terms of Mode 1, Mode E, all of those things are the exact same. There's still a exchange of session words out of band. What they did though was bump up the actual scrambling and encryption algorithms so that they're just more complicated, less easy to crack, especially with modern computing power with GPU fueled processes and stuff like that. There's so much processing power available to even consumers nowadays. A basic scrambling algorithm like BISS1 can be cracked in a matter of seconds, matter of minutes. For BISS2, we start to adopt AES 128 encryption, which, obviously government level crazy supercomputers and stuff like that are capable of cracking that in a couple minutes or so. For the basic person or, normal, I guess, everyday hacker, if you want to call them a normal everyday hacker, wouldn't be able to necessarily hack that in a good amount of time to be able to access that content. So it does enhance the security just because of the more complicated encryption. The other piece of this is also the DVB-CI scrambling. So before we were using DVB-CSA, and you remember me saying that it was hardware friendly and not software friendly. So it was great for ASIC-based FPGA implementations, where it was less favorable to software implementations. What's nice about DVB-CI, especially in the modern age of cloud computing and cloud workflows, or software-based decoders like RMD7000, for instance, DVB-CI scrambling is much more software-friendly, software-oriented scrambling algorithm. So it's easier to implement, much more lightweight, not necessarily less secure, but just an implementation. It's just a better algorithm for those types of workflows. So kind of stepping through, I'm actually skipping mode 1 because we don't care about mode 1 with BISS2. But again, this is the encrypted session word with a much more complicated hex key, and using the 128 scrambling, we're able to create our encrypted session words in order to lock down the signal. And of course, you can see that encrypted session word is much stronger because of the AES 128 scrambling algorithm. And then the IRDs, again, are able to take that ID and session word and do the scrambling. So again, very similar workflow to BISS1, just a stronger encryption and security there. And again, mode 0 means nothing. It's disabled, no security, free to air, no lockdown, just being able to receive those signals and decode is easy, and don't have to worry about doing any kind of descrambling. So we covered BISS1 and BISS2, but one of the things I did want to cover from a very high level, I didn't really necessarily want to dive into the nitty gritty of DVB-CI cams and smart cards, but this has been around for a very, very long time. And one of the key things that DVB-CI cams and smart cards have the ability to do is be able to give content providers control over who can receive their streams. So they can actually deauthorize on the fly individual cams based on the card IDs or the smart card IDs. And that gives them full control over if they detect some kind of security leak with a particular vendor or receiver decoder or turnaround platform, what have you. They're actually able to on the fly take that key out of the ECM and EMM tables and deauthorize that particular receiver or that particular cam and smart card from doing the descrambling of that signal. So now that piece of it is absolutely huge. And that's kind of the key takeaway from this slide, is that control gives content providers a lot more security, just the peace of mind that they have that control over who can actually descramble their streams. Obviously, there's some downsides to this. This is usually you get involved with a single smart card or cam vendor, the proprietary implementations. If you're a person that's worked in the lab with these cards, and these DVB or PCM CIA slots is actually what those slots are for the DVB-CI standard, they can be kind of fragile. They're a little bit annoying to use over and over again. The cams literally start to fall apart, separate. So from a logistics standpoint, a reusability standpoint, reliability standpoint, just of the physical hardware stuff in a lab environment or like a truck environment, this is maybe is less ideal as opposed to having something that's embedded in software or like an FPGA or an ASIC-based implementation like you would with BISS. But obviously this is way higher security, but obviously you're paying for it and having to deal kind of the headache of DVB-CI. All right, so we're going to dive into BISS CA and talk through that. But before we jump into that, my panelists are indicating we have some questions, and I will try to provide some answers.
We do. We have one question for you. Is BISS2 Mode E widely used in the market, or are people just using BISS1 mainly yet? What's your take on the market use?
So what we saw, and we actually saw this particular, I'm going to speak towards our MRD 7000 platform, just because it was the one that was exposed to a lot of these protocols, I think, before more of our like primary distribution, secondary distribution decoders. I think BISS1 I think is used because it's easy to implement. It's available on pretty much everything, and it's a easy thing to just put onto, make it, I guess, less easy for anybody to just download not download, but tune up a signal and then being able to decode the video. BISS2 I think was a very good kind of step in the right direction, because AES-128 is actually a very, very secure algorithm, and gives you a lot of added security without really changing any kind of workflows or anything like that. I think it was a middle ground though. I think everybody was just waiting for BISS CA to happen when the standard was actually updated from BISS1 to, we'll call that 2018 BISS2 and BISS CA edit to the BISS standard. BISS CA was actually already a part of that standard. Everybody was aware of it, but no one was able to onboard it and get the the scramblers and the descramblers and stuff in place. And then there's a little bit of kind of registering your IRDs with a particular content provider and stuff like that. There was a little bit of infrastructure that needed to be built around BISS CA, where BISS1 and BISS2, it was literally the exact same workflows. It was just a matter of whether or not you could implement it. So our MRD 7000 was exposed to BISS2 for quite a bit of contribution feeds, I'd say in like late 2018, and then over the course of 2019. We saw a lot of BISS2 Mode E with the MRD 7000, specifically around sporting events, contribution links, and stuff like that, just because it was just a higher order security and made a lot more sense. Now, going into late 2020 and looking to 2021, it looks like BISS CA is going to be the de facto standard. I think, like I was saying before, there's just too many advantages and enhanced security that we'll obviously dive into in this next section. That make, I think, a lot of sense for just about any content provider to hop on board with this particular protocol. But anyway, yeah, I guess that's been our exposure to it, and why you didn't see BISS2, for instance, in our MRD 6000 or 5840 or 4400 platforms, just because they were already in the primary and secondary distribution. BISS1 was just fine. We didn't really need to worry about it. But now that you see the adoption of BISS CA coming, we are starting to, as a vendor, as a hardware vendor, or a decoder vendor, take notice of that and add that to our other platforms. So. All right, what is BISS CA? What is it giving us that we didn't have before? So, like I just highlighted, introduced in April 2018 with the addition of BISS2. BISS CA was just another appendix, or I guess another chapter of the BISS standard. We get all of the enhanced security of BISS2 with the AES-128 and DVB-CI, scrambling algorithms and protocol and things like that. And of course, it's a standardized protocol that's interoperable across multiple platforms. Unlike DVB-CI, where you're kind of buying into a proprietary single vendor solution, this is interoperable with literally anybody in the market. It's a standard that can be adopted, which makes it really nice to have a multi-vendor solution, not only on the on the encode, the muxing, the modulation side, but also on the receiver side for whether it's a receiver decoder or a digital turnaround platform, something like that. As long as you support BISS CA, you can play nice with everybody else. And then, of course, not having any royalties. That's always nice, especially speaking as a product manager and having to deal with paying royalties for all the different technologies and stuff that we have to integrate into our platforms. It's nice to just look at a standard, be able to implement it, and really just start getting into the solutions and solving the problems of customers without having to worry about, oh gosh, I have to go pay this guy now just because I'm using his technology. It's just a nice smooth way of implementing technology. So that's always nice. I kind of touched on this a little bit already, but that DVB-CI scrambling algorithm is both software and hardware friendly. And so you'll see that actually in some of the later slides. I'll talk about the Sencore platforms, but I think this could be echoed across the industry, to be honest. you'll see BISS CA being implemented in cloud-based workflows with IP type workflows, or even satellite contribution links, where you tend to have more like hardware-based solutions that DVB-CI enables both software and hardware implementations. And of course, it works with satellite and IP delivery in this case as well, which of course, AES-128, I think if anybody gets involved with, the internet-based protocols, which I'm sure Jason will talk a little bit about tomorrow, you see AES-128, AES-256 get adopted by, protocols like HLS and SRT and ZXI and all those types of over the internet protocols. AES-128 is a very secure algorithm or encryption standard. So yeah, works great for IP and satellite workflows. All right, so looking at the basic diagram here, what we're doing is still randomly generating a session word in the encoder or multiplexer or modulator and inserting that session word into the ECM tables. Obviously, this is not done out of band. This is all done in band, actually in the transport stream itself. So those ECM tables will actually contain all of the session words that will be needed for the receiver to be able to scramble the stream. So there you have in your, in this case, NMRD 7000 is able to receive that transport stream, process the ECM tables, extract the session word, and start doing the descrambling process, if you will. We're going to add yet another layer on top of that for the session key, which will also be entered into the EMM table. Again, all in band. There's no exchange of keys or anything like that over email or phone or anything like that. And that encrypted session word is then created so that the session word isn't just like out in the open there. It is actually an encrypted session word for both the transmitting side and the receiving side. This is a really important piece here as well. This comes from the, I think what we've learned in the DVB-CI smart cards and cams is the rotation of the session words. So we can actually do this as quickly as every 10 seconds, rotate this session word. So even if you were able to, for instance, actually decrypt that session word or that encrypted session word, it's going to rotate again in another 10 seconds. And so you have to start that process all over again. So you got to think about that from a hacker standpoint. There's some, I don't know, new FIFA game on TV that's being broadcasted. I'm able to downlink that signal, and I'm starting to crack the code, if you will, or start to decrypt that session word. As soon as I start that process, I might have cracked it in, let's be completely unrealistic and say I've cracked it within a couple seconds. Well, 8 seconds later, it's going to change again. I have to start that whole process again. So now I've got 6 seconds of video that I recorded. Well, now I have to start the whole hacking process all over again in order to unlock a little bit of video. So really, even if you were able to crack it, you're getting chunks of video even, and can be completely useless to anybody actually able to, I guess, break the code, if you will. So I'm continuing on from the rotating key. We're receiving the encrypted session word via the ECM and EMM tables, and able to decrypt the encrypted session word and create the session word. The big piece here with BISS CA is the public and private key that is actually generated on the receivers themselves. So this is done with RSA 2048. Which takes a unique either hardware ID or ID within the IRD itself to create a public and private key. That private key is used to actually decipher the session key, and the public key is injected into the actual outgoing stream in the encoder or the multiplexer or the modulator. This is the piece that allows the content provider or the transmission side to be able to authorize or deauthorize individual IRDs. So in this example, when the public key is put into the entire scrambling process there, what you could do is actually just take that public key completely out of the list. That would deauthorize the MRD on the other side. So what we want to do is keep continuing to add those public keys to the list. And that way it authorizes all the receivers on the other end. So if there's any kind of detection of, you know, whether or not that somebody has been able to crack the code and now there's kind of a leak in the system, if you will, and things are getting pirated, what we would want to do is just remove MRD1 or MRD2 from the public key list on the transmission side, and then we would deauthorize the MRDs on the receiving side without having to affect anybody else in the chain, which is quite nice. This has been one of those things that, like I said, DVB-CI has been able to do for years and deauthorize smart cards or CAMs on an individual basis. This allows us to do this completely with just the public keys that are generated by the IRDs. Now, I'm sure the next question is, well, how the heck are the public keys actually getting to a particular content provider or transmitter? Well, there is actually going to be, I'll call it web portals. Eurovision's a really good example of this and how they've set it up. You know, any particular hardware vendor or affiliate or something like that can create a secure login account to this web portal. And then what they'll do is actually upload their public keys for all of their receivers to Eurovision. And then on a case-by-case basis, they can select which IRDs will be receiving a particular feed. That way Eurovision has a complete schedule of what's going to be happening, what's going to be broadcasted, what IRDs need to be authorized for this. They can then have the power to say, no, I don't want you to receive this because you haven't paid your bills or something like that. They actually have full control over who is able to receive it. They have full visibility into, you know, whose receivers are owned by who. It's a really nice system, and I will talk about that in a little bit more detail and kind of show you the web portal and how that's all going to work. But I would see a lot of other content providers doing this exact same thing, just because it allows for a secure exchange of those public keys and control by the content providers. So I didn't want to, I took this right out of the technical document from the EBU for BISS, BISS2, and BISS CA, but it's a nice family photo of all of the different algorithms and protocols and kind of how they're associated with each other, and kind of what we get and what we don't get for particular modes, and whether or not it's BISS1 or BISS2 or BISS CA. It's a good kind of, I guess, a wrap up of all the things that we just talked about. Yeah, to talk about the receiver registration. So the EBU Eurovision actually has a portal to register the receivers. This is where you actually just submit your public keys that are downloaded directly off of the IRDs. So you would register with them as, like I said, as a hardware vendor or an affiliate or whoever needs to receive and Descramble the streams from Eurovision. Upload those public keys, and then you're pretty much off and running. One of the deadlines actually to register kind of the early implementations of this was September 30th. So we had quite a few of our IRDs getting registered and stuff like that with them. And there is the link there below if you wanted to go check that out and kind of see how the workflow is and how to create an account and things like that. Just to give you an idea what the single receiver public keys and then the multiple receiver CSV files look like. Don't worry, you can copy paste that all you want. This is actually from a Eurovision document, so I'm pretty sure that's just a generic public key. You're not going to get any special content if you enter that in anywhere. But what you're able to do is actually, from a single receiver standpoint, is download public keys from the receivers. It'll just be a .pub file that contains that text that you see on the very right-hand side. And then when you're uploading a lot of different, say you have a group of like 10, 20 receivers or something like that, you can actually generate a CSV file that has all of those pub files inside it. That way you get all of those public keys in a nice, you know, it actually names them here. If you can kind of see where I'm pointing here, IRDA, you could actually give it a nice specific name for each IRD, give it an ID in addition to the public key to keep it nice and organized. And this is actually taken out of one of the Eurovision's documents and how they would like it to be formatted. And I think everybody's kind of just taking this as the de facto workflow. Makes a lot of sense. It's very organized. I think just about everybody's generating files and stuff like this off of their IRDs and digital turnaround platforms and things like that. All right, so we covered BISS CA as a protocol, kind of the advantages and what it's giving our customers and what kind of the workflows and stuff look like. If there are any questions, no? Okay, cool. I will start talking about BISS CA with Sencore and kind of what we've done over the last 6 months in order to get BISS CA going on our products. So there's kind of an overall big workflow diagram, but really the big focus for us, obviously we are Sencore. We talk about Receiver Decoders all the time. It's really our flagship platforms. And so of course, anything from the MRD 7000, the software-based contribution decoder platform, all the way down to our primary distribution platforms like the MRD 6000 and MRD 58 and 4400s, all of the Atlas gear cards, the digital turnaround platforms, all have BISS CA Descrambling right now. Whether it's in beta format or released, we've got something that we can send to you, get you updated, issue a license and things like that, and you're off and running and being able to do all of the BISS CA Descrambling workflows that we talked about today. With the MRD 7000, we've got BISS CA, also the BISS1 and BISS2 support. Obviously this is the contribution level platform. This is the super high bit rate, super high bit rate HEVC 422 10-bit platform that we have 2110, SMPTE 2110 outputs, 12G SDI outputs, all of the things that a contribution level decoder platform needs. We do have BISS CA Descrambling. We've actually had this for, since probably July, I think is when we released it. And so this is kind of our first exposure to BISS CA and how to implement it and things like that. And one thing to point out across all the IRD platforms right now, it is a TS level descrambling. Multi-service descrambling for BISS CA is actually coming here in the next probably month or two is our plan, kind of see how things unfold. I know a lot of our partners and frenemies in the industry are also looking at doing multi-service descrambling with BISS CA as well. So of course we will follow suit as things are needed. But as I said before, and I talked a little bit, kind of what we've seen so far is mostly contribution and maybe some primary distribution where BISS CA is just scrambling the TS level and not necessarily the individual service level. And so just being able to descramble the TS level with BISS CA has been good enough for now, but we are definitely looking to expand upon that and do multi-service descrambling on all the platforms. Talked about this a little bit already, but the MRD and AG 2600, 4400, 5800, and 6000 now all have BISS CA support. Coming in Q4 2020, like I said before, we already have a beta available that is essentially like, it's pretty much fully baked, like what we're going to be releasing anyway. And so if you have the need, feel free to reach out to us. We can get you that beta version of software. It is a new license on top of the existing BISS1 descrambling that we have in those platforms, but it's just a simple software upgrade, a license application to the unit. So there's no new hardware. There shouldn't be any issues with, if you're concerned about, is my IRD too old or anything like that. If all you really need to do is update the unit to the latest version of software, get the license, apply the license, and you're off and running with BISS CA. So pretty simple. I also want to talk about our DMG 4000, our digital media gateway platform. So this is our, really, I think talking about BISS specifically, this is our contribution encoding and turnaround platform. So this platform has the ability to encode HEVC, H.264, JPEG XS, TICO, JPEG 2000, all of that great stuff in a single hardware-based platform. We do have BISS CA scrambling, especially for the satellite contribution, IP contribution workflows. This has BISS CA scrambling integrated into it already. So we're able to feed all of those workflows, with the MRD 7000, 6000, 1500, 4400, and have a nice, secure, I guess, Sencore solution or Sencore platform to support the new protocol. All right, that's it. Now you all know what BISS CA is and exactly how it works, and it's very straightforward and easy. I hope, maybe.
So yeah, we have a couple questions here.
Okay.
So the one is the biggest difference in the past with DVB-CI and BISS was that CI could be scrambled on a service level, and BISS was only ever on a transport stream level.
Yep.
Does BISS CA address this at all?
Yes, it does. So it will actually have the ability to do multi-service type scrambling, just like DVB-CI. We haven't implemented it ourselves. It's something that I think literally everybody's looking at doing, though. Like I said a little bit before, some of our partners and frenemies out there are already talking to us about when are we going to be supporting multi-service scrambling and descrambling in our platforms, and hopefully the next month or two we should be able to add on top of what we've already implemented. But yes, the answer is yes, it does have that ability. And one thing to note, and like I said a little bit before, was really, I think the short-term focus or the immediate need was the contribution workflow with BISS CA. So that's usually like, a TS with maybe a couple PIDs in it or something like that. And so you really only need TS level scrambling in that case. But as BISS CA starts to trickle down into your primary distribution and stuff like that, obviously there's going to be more services. Maybe you don't want to authorize every affiliate for every service that's in that stream. And that's where multi-service scrambling and descrambling is really powerful, especially with the BISS CA stuff, when we can deauthorize individual receivers and, you guys can decode this, you guys can decode this. You can kind of delineate all of that just like you would have been with DVB-CI in the past, but just with a, open software or a software-based solution. So yeah, hope that addresses the question.
Another question here, is Sencore or any other vendors developing an affiliate management system versus just loading CSVs and pub files into the mux or modulator? Are you aware of?
I am not myself, but I kind of look at what Eurovision has done. I guess is just like, I guess it's an example. I could see how people might want a kind of a BISS CA type management system. That makes absolute sense, especially if the BISS CA system kind of lived in kind of like a cloud type instance, and you're able to register all of your receivers and stuff in that kind of workflow. But I also look at it as, especially from a content provider, I think of the CBSs, the NBCs, in the US, but then I also think of like Eurosport, Eurovision, all of those guys in Europe. They have these kind of portals already, usually like web portals. And so it just gives them the ability to do the tracking and stuff themselves, as opposed to, having, a vendor or something like that potentially make them something that didn't fit their workflows quite as nicely. So I don't know. It's not that it couldn't happen, but I guess we haven't really considered it just because everybody has their own web portal already. At least so far they have.
All right.
There's one other one here. Have the content owners approved BISS CA for IP transport?
Oh yeah, it shouldn't be a problem. I'm not entirely sure it needs to be like authorized or anything like that.
I think some of those contracts dictate what needs to be used.
Okay.
I think the question is around that.
We haven't seen it yet. As far as what we've seen so far in the market, with what we've been exposed to with the early stuff with the MRD 7000, and now what we're getting exposed to with the other ASIC-based platforms, so far it's actually pretty much all satellite. Not that it's saying that it will stay that way. I could absolutely see BISS CA getting, being accepted as a, a security protocol, security workflow for IP workflows as well. The one thing that's interesting though is a lot of those IP workflows kind of already have their own security added to them right now, with AES 128, AES 256, RIST will have, DTLS and PSK and all that great stuff. So it's whether or not you want to keep it easy and just use what the protocol already has integrated into it, or if you want to take it a step further, implement something else entirely. I mean, that would give you a lot more, I guess, control though over who's able to receive and descramble things when you use like a BISS CA workflow. So there could be some advantages there. I think it just depends on how much work you're willing to put in to get that system turned up. So, yeah. Good to go? All right. Well, if you didn't already see it, we put up a poll for everybody to take, just as to let us know how you want to be followed up from the session. Obviously, we can email you a recording of the session. If you want to be contacted by an account manager, or if you have some ideas for future webinars, things like that, please let us know. But yeah, I thank you all for attending. And we'll be looking forward to presenting over the next couple of days. That is as webinar season. So we'll see you then. So thanks a lot, everybody. Appreciate it.